Hey there, welcome to Book Overflows, the podcast for software engineers by software engineers, where every week we read one of the best technical books in the world in an effort to improve our craft. I am Carter Morgan, and I'm joined here, as always, by my co-host, Nathan Toops. How are you doing, Nathan?
Doing great. Hey, everybody.
Well, thanks for joining. As always, if you're on an audio platform, make sure to leave a 5-star review. If you're on YouTube, make sure to like, comment, subscribe. I always throw YouTube out there. I found out it's very quickly becoming, I think, the top place to watch podcasts, which I find fascinating. But today is actually a very good day to watch the podcast on YouTube. You can also listen to it, because if you're on YouTube right now, you'll see that we are sharing our screen, which we don't normally do, because as our final kind of end of the year episode, we're going to go dark for 2 weeks after this. We are playing a game. We're playing Guess That Quote. And so if you're looking at the screen right now, you're going to see there's a couple things. There's a score up top. There's a quote, and then there's a list of all the books we've read, buttons of all the books we've read. This is a game that we've put together. You too can play it. It's game.bookoverflow.io, and it has been loaded up with lots of quotes from all the books we've read, and every single book that we've read, and it's just going to flash a quote at us, and we have to guess it. We have to figure out which book it's from. We're going to be playing on hard mode. There's a little toggle in the corner that gives you every single book to guess from, and I'll toggle it for you right now so you can see. If you toggle it to easy mode, it gives you 4 choices. And unless you break it like I do, because now toggling it back and forth isn't doing anything. So I'm just going to refresh the page, and we're not going to toggle it back and forth between hard and easy mode. That's a bug. We'll fix this. This is proof that Nathan and I are actually software engineers. We can actually build something. And it's also proof that I did not spend a ton of time building this thing. Nathan, what are your thoughts on this episode? On our very first Guess That Quote.
This is like my Achilles heel. When I'm doing, like trivia nights and things like that, like I love the idea of it, and I always underperform. So I'm going to set expectations very low. So if I do great today, then, I can be as excited as y'all are. Otherwise, it'll be fun to watch me misquote books. That'll be great.
I've been playing this, kind of testing it myself. I have a decent memory for quotes. Like my family reunions are like 70% movie quotes between my brothers and I. But I was surprising myself that I wasn't able to get all of this.
That's great. No. So you're in like the upper quartile, and I'll be in the bottom quartile. So we'll see how this goes.
So just a couple of notes up top. This is a game that you can play. It's game.bookoverflow.io. There's no leaderboard or anything. This is, it's a very simple application. Everything's served up through the front end. So it's like Wordle. If you want to cheat it, you can just use the Chrome Dev Tools and get a full list of all the quotes. I wouldn't do that because that's not so fun. So there's no leaderboard or anything. I think this will be a lot of fun. The other thing I want to say is that slow productivity is not an option here, even though that was one of the books we read. It was my number 1 book. The way that I load up the quotes is I export my highlights from my Amazon Kindle, and slow productivity for some reason wouldn't let me export my highlights. So it's not on here, which is lame because I would have loved to have talked about some of the quotes from the book. But it was also such a different book from what we've read that I think it would have been pretty obvious every time a quote popped up. So this is going to see if Nathan and I know our stuff. We'll talk about the quotes as we do them, and I think it'll be fun.
Yeah, this is nothing like getting humbled at the end of the year. So
this is our we did our accountability check, which was humbling. Our top 5. I guess that wasn't humbling, but that was fun to review. But this will humble us. So let's just get started with the first quote on the screen. We'll read the whole thing. Some quotes are longer than others, but we intend this not only to be a game, but kind of a fun way to review some of the key findings from the book, especially because any of the highlights, all of these quotes consist of the highlights I exported from my Kindle, and I only highlighted something if I thought it was particularly meaningful. So this should be a good way to review some of the kind of key points of every book. All right, so let's start with quote number 1. We have a score of 0 out of 0. We get, sometimes it may not be obvious which things matter the most. It can be particularly hard for younger developers who don't have much experience. In these situations, I recommend making a hypothesis. I think this is what matters most. Then commit to that hypothesis. Build the system under that assumption and see how it works out. Sorry, I got to move to the bigger screen so I can. Okay, very right. If your hypothesis was right, think about why it ended up being right and what clues there might have been that you can use in the future. If your hypothesis was wrong, that's still okay. Think about why it ended up being wrong and whether there were clues that you could have used to avoid this choice. Either way, you will learn from the experience and you will gradually make better and better choices. All right, Nathan, where do we think this is from?
Oh, man. Temperament-wise, this feels like Martin Fowler's refactoring.
I was thinking maybe Clean Coder.
Oh, see, and yes, but
that's by Bob Martin.
Yeah, I think it's definitely one of the Agile Manifesto folks, but I don't. I'm going to put it in that quadrant.
I know the other. I don't think it's quite fundamentals of software architecture because it's targeted towards younger developers, which I don't. There wasn't as much talk in that book about younger folks.
And it's not exact enough speech to be. And watch me eat my hat, but I don't think this is Ousterhout because Ousterhout would have been more succinct.
Yeah, that's a good point. Okay, so I think we're saying either refactoring or Clean Coder.
I'll let you be the tiebreaker. Whatever your gut tells you.
I say Clean Coder. Oh, it's a philosophy of software design.
Whoa! Oh, that's hilarious. Okay.
Oh, our apologies.
It was sitting on my shoulder, thinking maybe this was it, but I was like, I don't know. That's hilarious. I feel that was my number one book, so that's what I get.
Okay, not starting off strong. Okay,
it's okay.
So zero for one. Okay, what do we got next? Okay. I think this is a softball. Get CalFresh routinely faced the problem that applicants were afraid the site was a scam because it couldn't possibly be from a government agency. I mean, I think this is simple, right? Recoding America.
Definitely Recoding America. Yeah.
Okay. Yeah. So Recoding America. Boom. We got it. Yeah. I enjoyed Recoding America. That's another one that's full of a lot of great stories. And I think this Get CalFresh is one of the success stories she talked about, where I think this was the new process for getting food stamps in California that they were able to kind of really, streamline. So yeah, good anecdote there. Okay, we're doing bad. It says score 1 for 1 right now, but that's going to update to be 2 for 1 as soon as we move on to the next question. So okay, or 1 for 2, I should say. Okay. Good design allows you to add more details and features later on, but does not require you to build a massive solution up front. Beginning with a reasonable level of abstraction and iterating over it gives better results than trying to predict the future and build everything that might be needed later on. Is this a philosophy of software design again?
I'm on the fence. Gosh, this is really an excellent example of how things can blur together in just a short period of time. So good design, it may be... It allows you to add more features later on, and it doesn't require you to build a massive solution up front.
I mean, refactoring is all about that idea of, just build what you need, build it in a way that's easy to change, and then you can come back and add it to it later.
Okay.
We can't even switch to easy mode because
it
breaks the game.
No, it's fine. Let's just make this a humiliation ritual. This will be great. I'm going to go with design more details and features later on, but not require you to build a massive solution up front. So this is interesting. I think this might be refactoring or tidy first. That's my thought.
It could be tidy first.
Okay.
Oh man.
I'm going to say tidy first.
Tidy first,
but it's probably going to be Martin Fowler for that. So
I'll trust your gut on tidy first. What do we got?
No,
it's web scalability for startup engineers.
This is great.
Oh man!
So if you're beating us at home, congratulations.
Yeah, that's true. Great. Oh man, that is funny. Okay, so we didn't get that one. That was my top 3. I think my number 3 book.
No, I think this is we're gonna see a pattern here, which is like our best books are gonna be the ones we misquote all the time. So.
Oh gosh. Okay. So that's 1 for 3. And the only one we got was Recoding America. Okay. Moving on. Okay. Engineering practices matter when defining how evolvable an architecture can be. While continuous delivery practices don't guarantee evolutionary architecture, it is impossible without them. If this is not building evolutionary architectures, I'm going to scream.
Yeah, I really hope it is. Otherwise, it's given a shout out to evolutionary architecture in the fundamentals of architecture book. But I think evolutionary architecture is the safe bet here.
Okay, yep, we got it. Building Evolutionary Architecture is by Neal Ford, Rebecca Parsons, Pat
So
Kwan, Pramod, Sadalage.
we've gotten the 2 easy mode questions so far.
Pretty much. Yeah, this is, I like the distinction here between continuous delivery and evolutionary architecture, right? Like that's not, just because you have continuous delivery doesn't mean you have an architecture that's easy to evolve.
Right.
So
Actually,
they matter, but
this is something I've been bringing up a lot at work, which has been cool because, you know, it gives you, what I'll tell you, what's so powerful about it is it gives you permission to intelligently put things off that don't need to be made decisions on, because you're building it in a way that can be changed, right? You say, hey, with confidence, we'll do this naive implementation. We're going to do the naive implementation this way because we can change this part over time because that's the right abstraction, right? That's a really, really solid thing here.
That's been a huge lesson for me at work recently too. Just, you don't have to get everything perfect from the get-go as long as you're building it in a way where it's easy to come back to it. Now that's different from place to place, right?
Right.
Sometimes you work on something that has a huge blast radius, or you know, you're working on a very established product and you have to make sure, like the number one goal is just keeping it up. But especially if you're working at some place smaller or on a smaller team within a larger company, it can be really valuable just to, like you said, put things off to get something out the door immediately, and then
the last responsible moment is what they bring up a lot in fundamentals of software architecture. And then I will tell you though, if you do this too far, you also accumulate technical debt, right? And because if you write something off as easy to change later and you're wrong, then you actually do the antithesis of this, which is that you've made a decision that's not evolvable. So you have to be really, really careful with, you know, stating that this is an evolvable architecture. It's an art more than a science, I think.
I am writing down the bugs in this game as we play, just so so when it goes out to our listeners on Monday, they don't have to deal with them. Okay,
I love it.
So now we're at 3 of 4. Okay, that's not bad. Okay, might be another softball. The first thing to explain is that what ChatGPT is always fundamentally trying to do is to produce a reasonable continuation of whatever text it's got so far. Where by reasonable, we mean what one might expect someone to write after seeing what people have written on billions of web pages, etc. I mean, this has got to be, what is ChatGPT doing and why does it work, right?
Yeah.
Okay. I think that's, okay, that was a softball. Yeah, I love this book. This cracked my top 5. I loved our interview with Stephen Wolfram. Both great things to check out. I think this is a pretty basic, like, I think if you have a basic understanding of LLMs, you understand kind of what it's doing here, that it's, you know, a sophisticated guessing machine. It's producing that reasonable continuation. But I really enjoyed in this book learning about some things like temperature, right? That you could theoretically design an LLM that always reproduces the exact same response to a block of text, but that just kind of by trial and error, we've discovered that, you know, I think they call it a temperature of, like, I think 0.8, right? Produces that kind of randomness that makes it sound more human. I didn't know that before reading this book. I thought that was pretty neat.
Yeah, actually I haven't read it yet, but it's bookmarked. There's like a chat group that I'm in, and somebody just shared an academic paper called GSM Symbolic: Understanding the Limitations of Mathematical Reasoning in Large Language Models.
Oh, interesting.
It's a white paper, right? So, I mean, you know, it's an academic paper, but it's actually showing why it's bad at doing things like math, which is really interesting because I'll tell you, it'll give you a very convincing answer that's wrong. That's actually like messing up a bunch of students who are trying to cheat, because they will look like, anybody who knows the math will laugh at this and be like, this was obviously generated by a large language model because it just sounds like complete garbage. So maybe I'll try to put a link to that paper in the show notes.
Okay, well, let's see what we get next. The key danger in a method of extraction is a type conversion error. We have a better chance of avoiding those if we extract only methods that have a low coupling count. When we've identified a possible extraction, we should look back and find where each variable that is passed is declared to make sure that we get the method signature right. I'll point out that we have a score of 5 out of 5 now. That's not correct. I'm writing down
also
bugs as we do
also
this.
if you get the first we got the first question wrong and it didn't add that to the total.
Oh, it didn't add that to the total.
Yeah,
Okay.
so we should have
Well,
1 out of 2. This is great. So ignore the scoreboard. We have to
ignore the
debug.
score. I think we got 2 wrong. We got the first one wrong. A philosophy of software design was the right one, and then we got Artur Ejsmont one. So
Right.
I'm just keeping track with a pen and paper. We're
Right.
2 wrong out of, I believe this is our 6th question.
This is
now.
our 6th question. Yeah.
Okay, great. So ignore the score up there, folks. This is you're watching live. We're testing in prod, so to speak. Okay, so method extraction. So this has got to be like refactoring or maybe working effectively with legacy code.
That was my thought as well. The key danger in method extraction is a type conversion error. We have a better chance of avoiding those if we extract only methods that have a low coupling count. Ugh.
I'm going to say working effectively with legacy code because of the reference to coupling.
Okay.
I found that refactoring was a little more micro in how it talked about refactoring. It was
Right.
kind of just talking about the method. Working effectively with legacy code, was talking about kind of the code base as a whole, and coupling was a big point there.
I'm on the fence. I think it might be refactoring, but I like your answer. I think you're probably right. So I'm going to say that's my
Let's
backup.
see. Okay, nice.
Awesome.
All right, so we got it. Working effectively with legacy code.
That's great.
All right. Another great book.
Coupling was a huge part, and then also these like the error stuff, because a lot of it is dealing with gotchas that are.
Yeah. Okay, what do we got next? Now we have a score of 7 out of 6. I don't know what's going on, folks.
I love it.
But we'll have this fixed. Lastly, a key part many authors forget is that they too need to leave their ego at the door. It can be difficult. Sometimes the code we write can feel like an extension of ourselves. Sometimes we also tie our worth or ability as a developer to that same code. When we get any kind of feedback that is not aligned with what we expect, we can respond inadequately. Instead, remember that you are not your code.
I know this one.
What is this?
This definitely looks good to me.
Looks good to me.
That's my vote, and the reason is because
I think you're right. Yeah.
She wrote a decent amount about like getting your ego out of it so that you're not like starting a flame war.
Okay. Yeah, I was gonna say clean coder, but I think you're right that this looks good to me.
Mm-hmm.
By Adrian Braganza. Let's see. Ooh, very nice. Okay, nice. Okay, we had a rocky start, but we're doing good. We have a score out of 8 out of 6.
Yeah,
we're doing as good as we possibly could.
Can't wait till we get to divide by 0. That'll be good.
Right? Break the whole thing. Okay. But sometimes I wonder whether any of those engineers lay awake at night haunted by that image of Krista McAuliffe's mother and wishing they'd called Dan Rather. This is Clean Coder by Bob Martin. He starts the book off talking about the Challenger disaster.
That's right.
And how the engineers said that they were wrong. They knew that it was wrong.
Right.
Forwarded it up to management.
I will say, so my father actually is like a huge, he's a student of this because he actually did a bunch of safety work in the Air Force, but he also is like, he works in hyperbarics medicine. And hyperbarics is these pressure chambers originally for treating the bends if you ascend it too fast, but now it's used for all kinds of accelerated healing. The reason I bring this up is I don't think it was this clean. I think that Robert Martin has like a really good story here, but the way I've heard the story told, it's actually a story of cascading failures where everyone who had a set of responsibilities of like the errors that were generated were within the acceptable thresholds, but nobody had thought about the culmination of all errors cascading together, creating emergent problems, and which is. It doesn't sound as good in a story about standing up for yourself, but
it's I think Bob Martin does a good job framing it here, where he doesn't say like if those engineers had been real men or whatever, right, they would have called Dan Rather. But I think it's just kind of posing that question of like how responsible are we?
I think from a storytelling standpoint, it's a really great story. Did it actually reflect reality because it came down to like one area where engineers didn't stand up for themselves? I think that's an oversimplification, but that doesn't give you like a woo-woo cheerleading kind of call to action. But.
I like Better Call Saul. It's the companion series of Breaking Bad. You ever seen Breaking Bad or Better Call Saul, Nathan?
I've seen every episode of Breaking Bad beginning to end. I'd never watched Better Call Saul, and it was funny because I love that actor.
Oh yeah, Bob Odenkirk.
Bob Odenkirk is he's like, so I used to love this absurdist comedy called Tim and Eric. Awesome show.
I love
great
Tim
job.
and Eric. Oh gosh.
Yeah. So Bob Odenkirk was like a guest on there all the time, and he was also before Tim and Eric Awesome Show. Great job. It was Tom Goes to the Mayor. That was like their first show on forever ago, and he would be like just a random guest, and he was hilarious. Of course, also OG. He was on Mr. Show with.
I know he plays Tobias in Arrested Development.
Yes, he plays Tobias, which is another great show.
And, fantastic. Okay. And then he got his start, I think, working at SNL with Conan O'Brien. They were writers together.
Oh, interesting. I didn't realize that.
Oh yeah, Bob Odenkirk, he's great. Anyhow, YouTube's been recommending me clips from Better Call Saul. I really like Better Call Saul. I like Breaking Bad better.
He's a phenomenal. I mean, he's such a good actor, and it's cool that he's been able to slip into like serious roles and still bring some of that undertoned comedy to these serious things. So,
but one of the things it said kind of near the end of the series and kind of sums up a lot of the ethos of the show is I should have tried harder. And I think about that with this quote, right? Where it's like just that question of, like sometimes in our life we do the right thing. We try to make amends or whatever. Are there cases where we should have tried harder? And so I think that's kind of the question Uncle Bob's posing here. I agree as far as how rhetorically effective it is. That's up to the reader. But this is one of the reasons I liked Clean Coder. I just thought it was it had a lot of kind of fun little moments and stories like this that made it a lighter read, which was nice. Well, let's see what we get next. Okay. Hide implementation details. The implementation behind the interface should be hidden from the rest of the program so it can be changed without affecting or breaking anything. Ooh. My gut is saying a philosophy of software design. What are you thinking?
Implementation details. The implementation behind the interface should be hidden from the rest of the program so it can be changed without affecting anything. I think that is a very good guess.
It's that, or I was going to say maybe working effectively with legacy code. There's a lot of talk about abstraction in there too, especially for like creating mocks when testing. But I just the way this is, it's a little terse. It's more of like a command. That kind of sounds like John Ousterhout's writing style.
It also could be practice of programming.
Oh, it could be practice of programming.
Hide implementation. The implementation behind an interface should be hidden from the rest of the program so it can be changed without. Yeah,
I think practice of programming is what it is.
Oh man, I think, and I will throw this one out there. I also think we could be wildly wrong, and that this is like fundamental software architecture or something. So,
maybe.
I don't know.
I think
just do practice programming and continue the humiliation ritual. So,
no, we won't. It's practice of programming. Boom.
Okay.
Nice.
Yeah. This sounded like Rob Pike to me. So that was the thing. I was like, this is of the folks who can write succinct things that are statements of truth like this, like a proverb. Also, interfaces in Go are incredibly important. So
yeah, and especially because this is like a simpler idea. Like we get like hide implementation details. I see how that would be a little more like necessary to say back in the 90s. So
right.
That quote makes sense to me. Okay.
It's also interesting. I would say philosophically, you would think that this would fit into somebody who is doing like more refactoring type work, but you have to remember too that Rob Pike and John Ousterhout are fans of deep methods, right? Are deep interfaces. This idea that you leave it simple on the outside, but it actually can be 200 lines, 300 lines of code, or even more underneath it. Which is not necessarily how a lot of the refactoring type work does, where you break things up into lots of little pieces, right? And so I think this is a nuance where they both are effectively trying to go for this, but the willingness to say, look, make the interface as simple as possible, and then you can black box it, right? You can do all kinds of radical refactoring, and it doesn't affect anybody because you're not like exporting 50 different methods that all of a sudden you have to respond, be reasonable with. So.
Absolutely. Okay. All right. So only 2 wrong so far out of, this is our 13th, we think. I think the score is correct, or the count is correct if the score isn't. All right. Did you know that I invented voicemail? It's true. Actually, there were 3 of us who held a patent for voicemail. Oh, this is a brag. I know who this is from.
This is definitely Robert Martin.
This is Robert
Coder,
Martin.
the humble brag.
Yeah, the humble brag here. I think just looking at this, it's funny. His button has the Clean Coder has the full subtitle, but there are definitely some other books that have subtitles that they didn't get the full title. I don't know why that is. Okay. Yeah, this is Robert Martin. Okay. Yep. If you didn't know, Bob Martin invented voicemail. He holds the patent for voicemail. Pretty cool. I think it'd be cool to hold a patent like that, but that's not me. Okay. This might be another softball. Okay, good titles give you a hint about the PR with the description filling in the rest of the details. Excellent titles are to the point and self-explanatory without the rest of the PR. This Looks Good to Me by Adrian Berganza.
Totally. Yep.
Okay. Let's see. Boom. Okay. Yeah, I said it in our episodes where we covered Looks Good to Me. I said it with Adrian Berganza in our interview. Like, this is the definitive read about code reviews. I can't imagine a more comprehensive book. Adrian does a fantastic job with it. And I was seeing on LinkedIn the other day that the book is officially out now.
Yeah, I saw the same thing. Yeah, so you can grab it from any of your favorite booksellers or directly off of the O'Reilly website.
Yeah, if you're someone, especially if you're like
it's not O'Reilly, is it? Oh shoot,
Manning. I think it's Manning.
I think you're right. Looks good to me. Book. Yeah, it is Manning. Sorry, Manning.
That's okay, Manning. We appreciate you. Yeah, especially if you're like a team lead, who maybe feels like your code review processes aren't to snuff, or if you're, like that. That's who I think would be most helpful to, is like a team lead who has a lot of authority to kind of dictate what the code review process might look like, and you feel like yours aren't super productive. Like, this is the book to read. You will be left with no shortage of ideas on how to improve your code reviews. So, great book. Okay. Puzzling over some text to understand what's going on is a great thing if you're reading a detective novel, but not when you're reading code. This is Ousterhout, right?
I think you're right. This is definitely...
I think this is his chapter about comments.
Yep.
Okay. No, it's refactoring.
Interesting.
Dang it.
Hey, that's cool. Hey, look, it's always good too to see where there's alignment.
I know, right? I guess that's true.
Between these two schools of thought, because they do kind of butt up against each other and things like test-driven code and things like that.
And refactoring. So I sort of aligned this with John's his philosophy on comments and how he thinks comments are underrated. I think this is refactoring kind of advocates that philosophy for like readable code is better than clever code. And, if you can do something in one line, but it's hard to understand, break it up into 4 lines. If that makes it a little easier to read. Yep. So I subscribe to that philosophy myself. Sometimes it's a bit of a crutch just because I'm like, I don't know the clever way to do this. I'll just do this the simple way over 4 lines. But I think it makes for readable code, and I stand by it. And it looks like Martin Fowler does too. So
that's great.
Okay. If users must read the code of a method in order to use it, then there is no abstraction. Okay. This has got to be John Ousterhout, right?
If users must read the code of a method in order to use it, then there is no abstraction. Oh man, I'm so on the fence on this one.
What do you think it could be?
If they read the code of the method in order to use it, then there is no abstraction. I think you're right.
I think it's John Ousterhout.
Yeah.
This one.
Yes, I think you're right.
I want to say this one sat strongly with me. Just I don't know. I think there's a part of you that thinks like, oh, if you're a real engineer, you get deep in the nitty gritty of the code. I remember that was kind of like a light bulb moment for me by my first job. And this was back when I was in office, but seeing a senior engineer, he literally diving into the method calls from the library he was using and like looking at the code there. And it shocked me because like the libraries, third-party packages were like a black box to me. I didn't realize you could actually go in and reason about them.
Yep.
So I was like, oh, that's what real engineers do. And in that particular situation, that is what he needed to do because there was I don't remember what it was, but there was some sort of bug or he wasn't sure exactly how it was working. But I
You
think
need, yeah, you need to be able to do that. Ideally, you don't have to carry the burden of the cognitive load, right? So
yeah.
I think that's the whole idea of this quote is that, hey, you did it wrong. If your 10x or top engineer or whatever has to go through and like read the source code of everything to understand what's actually going on, that's a bummer, and it's a lot of stuff that they could be focused on other things with.
Yep. So it is a philosophy of software design. I ran into
Woo-hoo.
something like this similar at work.
Yep.
I work with, we have a Slack bot that's installed across all company channels, and which you can then send your own messages through. So it's really nice because if you want to send out like sort of like automated Slack messaging, you don't have to rig up your own Slack bot and get approval from like the Slack admins and things like that. You just use the company-wide Slack bot, which is cool. For reasons I don't understand as much, it's gated, or you don't interact with it with like the default Slack API. You interact with it via a custom API. Like there's that layer over it, which then interacts with the Slack API. I think that's really dumb, to be totally honest, which is funny because this was created earlier. We actually have at our company, we have a company-wide AI proxy, which is really neat, where basically I can go to the company website. With one click, you can generate tokens for the AI proxy. And then the AI proxy is just a thin layer. It conforms to OpenAI spec, so that you can interact with the OpenAI API really easily. So it's really cool because one, you can just get your credentials up and running super quickly. From a company-wide perspective, it helps them. All the LLM requests are made through one service. So they kind of, they're getting lots and lots of data about like how engineers are using large language models. And then it's cool because since it's model agnostic, you can swap out the model underneath while still using the company AI proxy. So I really like that. I wish with this Slackbot thing that they had basically done the same thing, but for the Slack API. Like I wish it was just a thin wrapper around the Slack API and I could just interact with that, because now I have to figure out like, okay, what's the custom API on top of it?
What language is this in again?
Which one?
The one that's hot swappable. You can swap the models.
Oh, I don't know what language that's actually written in.
It just reminds me. There's a Python framework called LangChain, and I wonder.
Oh, interesting. Maybe that's what it is.
I don't know. I'm just curious. It's always interesting to see what like SDKs have emerged out of this and where the abstractions are. That's cool.
Yeah. Anyhow, so but this like this Slackbot API I'm working with, like if you try to message a channel but that channel doesn't exist, it just returns a 500 error, which is really annoying. I wish it returned a 404. So I had to go and dive into that API code to figure out like, okay, where is this error actually happening? I think that's an example of like the abstraction being a little broken there.
Yeah, it's a pet peeve of mine when I had this battle with an engineering team a while back that they would bubble up whatever the error codes were from other systems. And so we had all these 500 errors, which I consider internal server errors.
Right? Oh, I agree.
And so even if an external service happens to give you an internal server error, I don't think that should go back to the end user, because we should expect that failures happen with external systems at times.
Yeah, right.
And so we would say, it should probably get downgraded to some sort of 400 error of some unavailability or, these other things, because from my observability background, 500 errors are typically Sev 1, Sev 0 type problems.
Yeah.
And so if you set thresholds to say any 5xx error gets alerting, and it's literally just like standard path error handling, then that's a huge burden on everybody.
I've never done alerting based on the kind of error. Like if it's a 500 or 400 or something
infrastructure
like that. But I like that.
Yeah, infrastructure folks will, because especially if you look at like load balancers, good example. You typically will get statistics on the type, like it'll be 2xx, 3xx, 4xx, and 5xx, right? Those will just show up statistically. And so you can do cool things like, well, maybe the Poisson distribution of a 500 error happens, but I want it to be a ratio of the 200 to 500 error ratio or something, right? So I can actually go in and say, give me, if error rates of 500 errors go above this threshold, then send out something's going on. Like something's happening. We should probably be, at least thinking about it. And so that's why especially if you're doing like network level stuff, it can be a signal if you do your error messaging correctly, right?
And now that I'm thinking about it, I think I actually might have done this in the past. I know that at least we broke it out on our graphs as different, like we knew if it was a 500 or 400 error. But I think I'm just now realizing that the thresholds might have been different for each one. It's a good good thing to know. All right, what do we got next? Okay. Our message is this: try to write software that works within the intersection of the various standards, interfaces, and environments it must accommodate. Don't fix every portability problem by adding special code. Instead, adapt the software to work within the new constraints. Use abstraction and encapsulation to restrict and control unavoidable, non-portable code. By staying within the intersection of constraints and by localizing system dependencies, your code will become cleaner and more general as it is ported. What are you thinking, Nathan?
There's several overlaps here that, let's see, I'm trying to think about the concerns here. Our message is this. So they're referring to themselves as an R, which makes me think that this is a group written book.
We're getting into the meta here.
Yeah. I think this might be fundamentals of software architecture.
See, I think it's the practice of programming. I think portability was a much bigger problem in the 90s than in the 2010s when fundamentals was written.
Adapt the software to work with the new constraints. Use abstraction and encapsulation. Okay, we can go for that, but I think it's fundamentals of software architecture.
No, I'll do fundamentals. You're more confident than I am, and also if I'm right, I get it. Laugh at you.
Exactly, it's a win-win situation.
Okay, fundamentals. It's practice of programming. Ah, dang. Okay,
you're right.
I think the portability is what stood out to me, but that was a good catch. That because of the hour that it was a group book.
Yeah, okay. That's so cool. Also, I will say the other tell is the heavy use of colons. So the last time that they had one, there was a colon in there too. I'm doing some metadata analysis.
Okay, what do we got next? It is easier to comment everything rather than spend energy worrying about whether a comment is needed. This has got to be a philosophy of software design, right?
I think you're probably right. I think you're right. Okay. Let's go with it.
Okay. I think we had just talked about Ousterhout. Yep. Philosophy of software design.
Yep.
Just talked about how he is very pro comment.
I am also a fan. I also try to think of it as like writing it to an intern. Like if I wrote my comments for the audience of an intern who had to look at my code, 2 years from now and I don't remember it either, can I write about the expected behavior of this thing? And make it so that if somebody just hops into my code, they can just stick to that level and don't have to actually like read all the inner workings.
Yeah. Well, and I think this is as kind of like a more macro philosophy, right? Of like, is it easier to do the thing? Sometimes it's just easier to do the thing than to expend the mental energy worrying about whether or not to do the thing. My boss had kind of contacted me and some of the documentation I'd written, one of our links had become outdated. And he's like, it's not urgent. Can you just make sure that it gets taken care of? I was like, okay, I can add this to my backlog and kind of have the mental overhead of figuring out when this is going to get done, or I can take 5 minutes right now to update it. Right. Yep. So even though it wasn't urgent, didn't need to be done then, it was so easy that I just thought the 5 minutes now would be worth the mental overhead later. So yeah, it's a good thought as you're prioritizing your tasks. Okay. There are a few problems with the round robin DNS approach, with the biggest issue being that it is not transparent to the clients. You cannot remove a server out of rotation because clients might have its IP address cached. You cannot add a server to increase capacity either, because clients who already have resolved the domain name will keep connecting to the same server, then cache your DNS records for as long as the time to live policy allows. Using round robin DNS to distribute traffic directly to your web servers makes server management and failure recovery much more complicated. And I would advise against using this strategy in production. This has got to be web scalability for software.
It has to be. It has to be.
No one else has gotten into the nitty gritty so much of a traffic distribution. Yep. Web Scalability by Artur Ejsmont. This is I like this because the first time you hear about round robin DNS load balancing, and if you're not familiar with that concept, it's the idea of basically like one way you could balance your traffic is in your DNS record itself you could just, because the DNS record can resolve to multiple IP addresses, you could just list all the IP addresses of your server, and then you're kind of farming it out to the DNS system, right? To route your traffic. But I like that, it's not transparent. And I really like his points about failure recovery here, right? That like, if one of your servers goes down, you can't just remove it from the system. You're still going to get traffic routed to it. So I've seen this used sometimes in conjunction with like load balancers, because a load balancer is much more like, it's much less likely to go down. And so maybe you have like 4 load balancers, and then that's what your DNS record resolves to, is those 4. And so you're kind of doing a round robin to your load balancers, and then you're using your load balancers from there. This is really when you're getting to like that's what this whole book is about, right? When you're scaling to lots and lots and lots of users is when you need to be thinking out these strategies. Not all of us have to deal with that kind of scale.
Yeah. And some things have fallen out of fashion. Like you used to see this a lot, or you still see this a lot with like MX records, which is like when you're, those are to map your web servers. I mean, so your mail servers. Like traditionally, like let's say if you G Suite or something, or Google Workspace, you would point your custom domain to these like 4 MX servers. Google's recently changed that. It's a single DNS record that goes to it. Yeah, because you can do load balancing in more intelligent ways, and the DNS infrastructure fundamentally shifted. But it's still it's an interesting way of doing stuff. But everything's a trade-off. Yeah.
All right, so that is, let's see. That is question. We're on to 22. Let's go to 30, and then we'll see how we do. We've gotten 4 wrong so far, so we're not doing too bad. In general, the farther a comment is from the code it describes, the more abstract it should be. This reduces the likelihood that the comment will be invalidated by code changes. This I think is, again, a philosophy of software design. How funny we're getting so many stuff. If it's from this, I think we're just getting a lot of stuff about comments in this round. Because I think this is addressing the criticism of the comments can lie, the code can't, and that comments are much more likely to go out of date. And so I think he kind of talks about a lot of strategies on how can you make sure your comments don't go out of date, and this kind of proximity that he proposes is a solution.
It's the best guess. I think we could be wrong, but I think it's the best guess.
What do you think is the other option?
That's the thing, is I have uncertainty around that.
Okay. Let's try it. Yep. Philosophy of software design. Yeah, John Ousterhout, he's got a lot of thoughts on comments. He has a lot of thoughts on a lot of other stuff. I don't know why we're just getting comments. Maybe I highlighted a lot of commenting stuff in particular. But okay. So moving on to 24. If you find it difficult to come up with a name for a particular variable that is precise, intuitive, and not too long, this is a red flag. It suggests that the variable may not have a clear definition of purpose. When this happens, consider alternative factorings. For example, perhaps you're trying to use a single variable to represent several things. If so, separating the representation into multiple variables may result in a simpler definition for each variable. The process of choosing good names can improve your design by identifying weaknesses. Ooh. I was all on board with the practice of programming until design came up at the end. I don't think John Ousterhout talks a lot about naming stuff in his book.
If you find it difficult to come up with a name for a particular variable that is precise, intuitive, and not too long, this is a red flag. It suggests that the variable may not have a clear definition.
What do you think?
It's talking about alternative factorings.
Yeah, that made me think.
I think this might be refactoring.
It very well could be refactoring. The other thing I'm thinking, because my other thought with a practice of programming was like, hey, this is kind of advice has become a little old hat at this point, which makes me think this is a book that was written in the 90s, but refactoring was also written in the 90s. I'll take a flyer. I'll say refactoring. A philosophy of software design. Dang it.
That's hilarious.
I know. Man alive.
I mean, it's good advice. That's the
thing.
Is.
It's very good advice. And that's, I said like, this must have been written in the 90s. No, philosophy of software design was written in 2018.
Good names can improve your design by identifying weaknesses, which is
He's talking about
Absolutely
design.
correct. Yeah.
It's a philosophy of software design. Okay, we missed that one. There's just no way those tests can be anywhere near as incisive as tests written first. Ooh. Bob Martin's the test-driven development king.
There's no way that those tests can be anywhere near as incisive. Okay.
Incisive.
Test written first.
This prose reminds me of him. He's very
Yeah,
he's a takesman.
Yeah, I'm not confident, but I think that's probably our best guess.
It's that or refactoring.
Yeah, exactly.
I'm gonna say Clean Coder. It is Clean Coder by Bob Martin. Yep, we know your fiery style. Okay, question 26. As a principle, library routine should not just die when an error occurs. Error status should be returned to the caller for appropriate action, nor should they print messages or pop up dialog boxes, since they may be running in an environment where a message would interfere with something else. This feels like practice of programming to me.
Me too.
You think so? Yeah. The pop-up dialog boxes. No one really talks about pop-ups anymore. I would call this a modal or something.
Yeah.
Oh, maybe not. Okay, practice of programming by Brian Kernhan and Rob Pike. Very nice.
Makes total sense because it's all Rob Pike's a big Go. Everything is a value, including errors. Like there's not like a separate control flow, which is kind of controversial. But it really encourages you to just handle things in a certain way, and that meets up with that quote really well.
Very nice. Okay. Many of the scalability issues encountered in real-world projects can be boiled down to violations of core design principles. Software design principles are more abstract and more general than scalability itself, but they lay down a solid foundation for building scalable software. Now, this seems like web scalability, but I actually think it's fundamentals of software architecture.
Many scalability issues encountered in real-world projects can be boiled down to violations of core design principles, software design principles. I think you're right.
I think so. I think that because they do that chapter on all the ilities, right? Kind of the.
Let's go for it.
Okay. Fundamental software architecture. Oh, dang it. It was web scalability for startup engineering.
At least we were wrong together.
I know, right? Oh, Artur. If he'd come on the podcast, this wouldn't have happened. All right. Let's see.
I don't
moving
know.
on.
John Ousterhout came on, and I marked this as my favorite book, and it's where most of my errors are. So
I know we're not.
I'm consistently not attributing quotes to my favorite book. So.
Acceptance tests are not unit tests. Unit tests are written by programmers for programmers. They are formal design documents that describe the lowest level structure and behavior of the code. The audience is programmers, not business. Acceptance tests are written by the business for the business, even when you, the developer, end up writing them. They are formal requirements documents that specify how the system should behave from the business's point of view. The audience is the business and the programmers.
Oh, this is Robert. This is Uncle Bob all the way.
Yeah.
I'm a professional.
Yeah.
I'm a professional.
He is a professional. Yep, Clean Coder. I still am not quite sure what an acceptance test is and how it differs. Is he talking is this just another word for end-to-end tests?
Acceptance tests are QA. So basically what we're doing right now is actually QA, right?
Well,
so,
yeah. Yeah, but I'm the
ideally we should play the game of QA's job should be really boring, but QA is also like the masterminds that are like,
Yeah.
No, acceptance. So in formal Scrum methodology, any story that you have should have an acceptance test, and this should be something the business understands that the outcome is, right? So that's really what that comes down to.
Okay. So this will be our final one, I believe. Well, let me click enter. Yeah, so I believe this is question number 30. Like I said, I'm not super confident of this score up top. And I have here on just on my paper that we've gotten 6 wrong out of 30.
Feels like more than that, but sure.
Yeah.
I feel like half of them have been wrong, but maybe it's just me being wrong and the group being correct. So
this has a swear word in it, but I don't swear, so I'm going to cover that up, folks. It says, those folks, don't worry about it. They're in such deep trouble, they're all covering their butts and throwing each other under the bus. I doubt they'll even remember what you said by the end of the day. Ooh, and this is a giveaway because it's a quote, but it's in quotation marks. So okay. I think I know what this is from. What do you think, Nathan?
Oh, those folks, don't worry about it. This feels like it might be Uncle Bob again, but I'm not sure.
It's Unicorn Project.
Oh, you're right.
Yeah. I think this one Maxine has a bit of an outburst in the kind of meeting where they decide they're going to
You're
launch.
Right. That's absolutely correct.
Unicorn Project. Yep, Unicorn Project by Gene Kim. Fantastic. Yeah. It's another great book, and definitely, aside from maybe Slow Productivity, the most unique book we read this year, just because it's a narrative, right? I don't know how many times we're going to get to do that.
I actually just recommended. So there's a woman that I know, a good friend of ours, to my wife and me, and she actually has a background in working in HR, in the human resource stuff, people stuff, and but it's interesting. HR ends up having to be involved with a lot of software projects these days because there's a lot of like automation with staff and these other things. And she was outlining a bunch of dysfunction and like why they had these super old systems and they can't do anything and it always takes way longer. And I was like, you should read the Unicorn Project. That was, and it, because again, she's kind of learned to code somewhat, mostly because it's taken so long for software folks at her company to like help her with like generating reports or doing those other things. And I was like, I think you're going to laugh and cry when you read this book. So
yeah, well, that listeners, if you kept a tally better than we did, let us know if we're wrong. But by my guess, that was 30 questions. We got 6 wrong, so 80%. I don't know. I don't feel like that's too bad.
Yeah, we're a B student. That's a B student right there.
There we go. That was me in high school.
Same.
Yeah. And look at us now hosting a mildly successful software engineering podcast.
Yeah, getting all the questions wrong for my favorite book. So most of them. I think it was.
We'll be emailing out the apology letters. We'll say next year if we do this again, if we get below 50%, you get an extra bonus episode, which just consists of me and Nathan silently writing apology letters to the authors and mailing them out.
Right. Good. Okay.
Well, thanks for tuning in, everyone. We thought this was kind of a fun way to round out the first year of Book Overflow. As always, we say in the podcast, this podcast is still in its infancy. And so you have a big say in kind of how things go. So if you thought this was a fun game and want to see us play it more, let us know. I mean, we like the idea of making it kind of a yearly thing, but maybe we'll make it an every 6 months thing. We talked about that, our accountability check, right? That it was just, if we tried, our accountability episode would be like 3 hours long if we did it over the course of a year. So maybe this becomes a 6-month thing. I don't know. But let us know. And thanks so much for tuning in. If you're here with us to the end, you're a true fan, and we really do appreciate it. And we're excited for next year. We've got, if you go look at www.bookoverflow.io, you can see that we've already got several great books queued up for the first couple weeks of the year. And then we'll go from there. And yeah, Nathan, do you have any closing thoughts on Book Overflow 2024?
Hey, I'm excited to see what 2025 brings us. And yeah, we're hitting the ground running. A software engineer's guide book, which I think we've been really excited about. And the dark horse that I threw in there is hypermedia systems. So we're going to get real in the weeds on a contrarian hot take of HTMX and JavaScript minimalism. So we'll see how that goes.
And chime in if you want us to cover designing data-intensive applications. We have gotten that from some listeners. That's a book I would like to read. It's about 800 pages. It would, at the very least, be a 4-parter, and I think it would more likely be a 5-parter.
I think you're right.
Because it's pretty dense.
I think we should tackle it. That's my vote. And
I think we should too, but just listeners, let us know, just because that's one of those things that, like, once we do it, we're going to be in the thick of it for a long time.
I will say though, we might want to wait till you finish with graduate algorithms.
Yeah, I was about to say, yeah. Next semester, should everything go well, is my last semester of my master's degree. So that might wait until like June or so. But yeah, that's a wrap on Book Overflow 2024. Again, thanks so much for coming along for the ride. We I've been really pleased at how many people are listening, and we just really appreciate all of your support. You can always talk to us at contact@bookoverflow.io, or on Twitter. You can find the podcast at bookoverflowpod, or me on Twitter at Carter Morgan. You can find Nathan and all of his work with his newsletter, Functionally Imperative, at www.functionallyimperative.com, which also has links to his YouTube channel with interviews for Functionally Imperative. And yeah, just stay in touch. We're going to go dark for a couple weeks. We'll be back at the beginning of the new year. And thank you so much, everyone, for tuning in to Book Overflow. Merry Christmas, Happy Holidays, however you choose to spend this time of the year. We hope that you have a great time and are able to enjoy this nice winter break we got coming up. See you around, folks.